Let's start with our essential question. It will be, what causes plates to move? As I go, I'm going to first number the paragraphs, and then I'm going to highlight some things that are key terms. And then you can also highlight what you think is important. We'll number the figure as well. I'll go ahead and number the last figure too. Okay, you can follow along with me, and like I said, you may highlight things that you think are important, but I'm also going to be highlighting some key terms that you should know. In the early 1960s, geologists developed an exciting new theory called plate tectonics. The plate tectonics theory proposed that Earth's lithosphere, which is made of crust and uppermost part of the mantle, is not a continuous sheet of solid rock material. Instead, the lithosphere is divided into about 12 sections called plates. The plates float on the part of the mantle called the asthenosphere, which has the property called plasticity. Plasticity allows the plates to move across the top of it, carrying the continents and ocean basins with them as they move. For example, North America and part of the Atlantic Ocean are on the North American plate. Plates are thought to move because of convection currents in the mantle. Convection currents can cause the plates to collide, pull apart, or slide past each other. In the figure here, the very top is the crust, and it is part of another big section called the lithosphere. This is what we are basically standing on. Right underneath is the asthenosphere. So when we did the lab yesterday or the other day, we used frosting to model the asthenosphere. And then you have the rest of the mantle, and then your outer and inner core. In the mantle, this is where you have your convection currents happening. It's the rising and falling of magma inside the Earth, and this is what's causing the plates to move around. The theory of plate tectonics provides an explanation for the way many geological events occur. As you discovered in Explore, mountain building, earthquakes, and volcanoes take place along the plate boundaries. Let's go ahead and highlight that sentence. New crust forms at the spreading centers of mid-ocean ridges, while old ocean crust is being destroyed at subduction zones. 3 different types of plate boundaries. Divergent, convergent, and transform boundaries can be identified when looking at different geological events. Divergent boundaries. New ocean crust forms at rift valleys, where 2 plates diverge or pull away from each other. Deep within the earth, hot molten rock called magma oozes out from the cracks along these rifts and hardens to form new crust. When magma reaches the surface of Earth, it is called lava. Over time, the lava builds up and forms huge underwater mountain ranges along the ocean floor. These mountain ranges are called mid-ocean ridges. This continuous mid-ocean ridge extends for 50,000 kilometers, nearly circling the entire Earth. When the mid-ocean ridge builds up enough height to extend above the water surface, it forms an island. Iceland is an example of such an island. Located at a diverging plate boundary between North American and the Eurasian plates, Iceland is a part of the Mid-Atlantic Ridge. For the last 250 million years, Europe and North America have slowly been moving away from each other, causing the Atlantic Ocean to grow wider as new crust has been added to each plate. This type of boundary is called constructive. since it builds new materials onto the edges of the plates. Seafloor spreading occurs at divergent boundaries. And then you can see a picture of a divergent boundary right here. Convergent boundaries. Just as some plates are diverging or moving away from each other, other plates are converging or moving toward each other. The types of crust at their leading edge determine the result of the converging motion. There are three types of convergent plate boundaries: continental-continental, oceanic-continental, and oceanic-oceanic. Continental-continental convergent boundaries. When two plates carrying continents run into each other, the collision usually crumples the leading edge of both plates. See figure 5.22. Lofty, folded mountain ranges are created. The Himalayas are a great mountain range in Asia, 1,500 miles in length, extending from Pakistan to Bhutan. The Himalayas formed when India, the Indo-Australian plate, collided with the plate carrying Asia, the Eurasia plate. The highest peak in the Himalayas is Mount Everest, the tallest mountain on Earth. The Appalachian Mountains, the Alps, and the Ural Mountains are all thought to have formed as a result of continental-continental convergent collision. I'm going to go back and highlight these mountain ranges. Let's move on to the next part. Continental-oceanic convergent boundaries. If two plates collide and one is made of ocean crust and the other is made of continental crust, a deep trench forms in the ocean floor. The denser ocean crust bends down and slides under the edge of the less dense continental crust. This process is called subduction. As the lower plate is pushed under, it eventually begins to melt. The melted rock or magma from the subducted plate is less dense than the mantle rock and begins to move upward, often fueling volcanoes, which form volcanic mountain ranges on the upper plate. The Andes Mountains and the Peru-Chile Trench along the western coast of South America are the result of subduction. Areas of subduction are called destructive boundaries because older plate material is destroyed. And then this is where the plate that's sinking, as it sinks down, it melts, and then some of the lava rises, creating a volcanic mountain range in that process. And right in between is where you would get the trench. Trenches are formed by convergent plate boundaries between a continent and an ocean plate, or two ocean plates, which is the last one. Oceanic convergent boundaries. Collisions can also occur between two oceanic plates. The Aleutian Islands that form an arc off the coast of Alaska were created in such a way. One oceanic plate is subducted beneath the other oceanic plate along a trench on the ocean floor. As a result, a string of underwater volcanic mountains erupts. Once the mountains extend above the edge of the ocean water, a curved pattern of islands called island arcs forms. Japan, the Philippines, and the Caribbean islands are all examples of island arcs. So see, in this example, these would be the islands forming from a plate subducting, causing magma to rise and form these volcanoes. The next one is transform boundaries. Sometimes two plates slide past each other, as the Pacific and North American plates are doing along California's San Andreas Fault. These types of plate boundaries are called transform boundaries. A fault is a break in the Earth's crust and is caused by stresses related to plate movements. This shearing motion at the transform fault often causes earthquakes, but neither plate is destroyed in the sideways motion. Hotspots. In some locations, a narrow plume of hot material rises up through the mantle to a hotspot under the plate. The extra heat melts some of the mantle rock, which makes its way up through the plate to form a volcano. As the plate slowly moves over a stationary hotspot, a volcano forms. Eventually, there is a line of volcanoes as the plate moves across the hotspot. It is important to remember that the plate moves across the hotspot, but the hotspot does not move. Once a volcano drifts past a hotspot, it becomes inactive, but a new active volcano forms over the hotspot. A hotspot under the Pacific plate formed the Hawaiian Islands in this way. Another hotspot is located beneath Yellowstone National Park. So I'm going to go back and highlight it's important to remember that the plate moves across the hotspot, but the hotspot does not move. In the last graphic, you can see the convection current. So as it's pulling this way in opposite directions, it's pulling the plate apart at this location. So here's where you have your seafloor spreading. And then it's also pulling the plate this way, which is causing it to crash into the continental plate or converge, and where you get mountain formation, volcanoes, and then a trench along the edge here. Same thing on the opposite side. You have some volcanoes forming, or some islands, I think in this case, and you get another trench between those two as the plate is being pulled in this direction.